Assalamu alaikum dear students. This is physics paper 2 AS level, and this paper is 9702 paper 23, and this is basically October November 2022. So we are trying to solve this paper. Actually, I have already solved this paper just to save the time, and quickly we will try to understand what are the main points of any question, and of course how we can use equations and what will be the method of solving all these things. So question number 1 is here: the rate of flow Q of a liquid along a narrow pipe of length L and radius R is given by Q is equal to alpha R power 4 divided by L, where alpha is a constant. An experiment is carried out to determine the value of alpha. The data from the experiment are shown in table 1.1. So this is the situation. They have given you here the data and the quantity Q, R and L they have given you. And as you can see here in the beginning of the question, that Q is the rate of flow of a liquid. So it means that the rate of flow means how you can say many liters or meter cubes of water are flowing per unit time. So the unit is simply meter cube per second. They have given you here the value of Q. Similarly, R, as you can see that this is the radius of the pipe, so of course the unit is meter, and then you have the length L as well, which is in meter again. And of course for all these you have values. On the other side, in the another column, they have given you the percentage uncertainties of these quantities. Percentage uncertainties are given, so be careful. As far as the part A of this question is concerned, use information use information in table 1.1 to show that the SI base units of alpha is s power minus 1 or second power minus 1. So simply what you have to do, just use the equation Q is equal to alpha R power 4 L divided by L, and you have to write in this way that unit of Q is equal to unit of alpha into unit of R power 4 divided by unit of L. So all these units you already have. So just write these units, and you can see here that meter, and over here you have meter power 4. So these you can say powers will cancel out, and on the other hand you will get meter cube second power minus 1 unit of alpha into meter cube. And as you can see that very simply you can cancel out meter cube from both sides, so nothing but the unit of alpha you are getting is unit of alpha is second power minus 1, and actually this is you have to show. So remember this thing, that whenever they are asking to show or to verify or something like this, so the situation is that they have already given you the answer, so you have to only get that answer. So the mark is only 1, but you have to do all these steps. In part B, show that the percentage uncertainties in alpha is 15%. So remember this point, that whenever you are going to find the percentage of any quantity, what you can write here simply, that percentage of alpha is equal to percentage of Q plus percentage of L, the length, and 4 into percentage of R. Remember this thing, that here you have power 4, and when you will write the percentages, this power will come as the value or the coefficient. So simply they have given you here the values. So the percentage uncertainty of Q they have given you as 3, percentage uncertainty of L they have given you as 4, and percentage uncertainty of radius is given as 2. So these are the values you have, and ultimately you are getting very simply the percentage of alpha. And of course, if you want to get the detail of this the question as far as the theory is concerned, so you can go to my lecture on the uncertainty. So this is what we have. Again, a very simple formula. Remember this thing, that whenever you will have a situation like this, that you have, like suppose x and y, and you need z, so simply you can say that the percentage of z will be equal to percentage of x plus percentage of y. Or even if you have the situation like z is equal to x divided by y, the same situation will be, yani percentage of z will be percentage of x plus percentage of y. There will be no division like situation here. As far as the formula of the percentage uncertainty is concerned, it's simply the addition. So remember this point, that you need not to go for the you can say a situation of subtraction. So whether you have the product, or you have the division, in both the cases the percentage uncertainties will be written as the sum of the percentages of the given quantities. Only one thing you have to notice here, that if you have suppose power like x power m and y power n, so these powers will come as their values or coefficients. So this is the situation here. So remember this point. Okay, the part C, calculate alpha with its absolute uncertainty. With absolute uncertainty, give your answer to an appropriate number of significant figures. So this is very important. So first of all, whenever you want to get the value of alpha, value of alpha means that you have to write the formula for alpha. So as you can see that here you have the value, and in your concern, first concern is that you need to get the value. So to get the value, you have to make the alpha the subject, you can say, so QL divided by R power 4. This will be your formula, and here with the help of this formula, when you will put all these values here for Q, L and R power 4, you will get this value. So this is the value what they are asking for. Calculate alpha. Alpha means the value. So you have calculated the value. Then they are asking with its absolute uncertainty. So when you are interested in absolute uncertainty, this will be the formula. How you will write the percentage uncertainty, as actually we have already written here, percentage uncertainty of alpha will be equal to the percentage uncertainty of Q plus percentage uncertainty of length L and percentage uncertainty of R radius, and of course the 4 as a value or coefficient is here. But the point is that you need to get the absolute uncertainty. So this is the absolute uncertainty here, and this is the value of alpha which you have already calculated. So when you will go back, you will see that basically all this part you have already calculated, and this is nothing but here. So the value is 15, and when you will use this value of 15 here with this del alpha divided by alpha into 100, so very simply you can get the value of del alpha, and this del alpha is nothing but the absolute uncertainty. So how you will write? Remember one thing, that when you will calculate, possibly you are getting the value like 4 into 10 to the power 6. So just to make the power same, what we did, we have written in this way, that 0.4 into 10 to the power 7. And this is the situation here, that here you have 2.6 as the value, of course with 10 to the power 7, and on the other hand the absolute uncertainty is 0.4 into 10 to the power 7. So they have already given you the 10 to the power 7 into you can say in the form of as a sort of common factor. So 2.6 plus minus 0.4 will be simply your answer, of course with 10 to the power 7 here. And you already have actually discussed that the unit is 10 is second power minus 1. So here you have already have the unit as well. So this is how you are going to calculate this whole you can say thing, and this is the part C of question 1. Let's move to question 2. The engine of a toy rocket pushes gases vertically downwards. Yani if you are just making a rocket here, so you can say that the gases are coming out of the rocket, and the situation is that of course the gases are going downwards, vertically downwards, and what is happening, and this results in the rocket accelerating vertically upwards from the ground. So actually what is happening in this case, the force is acting you can say on the gases, and this force is pushing the gases downwards, and of course because of this the rocket is moving upward as a reaction. So they are explaining here this point. The rocket starts to move from the rest at time t is equal to 0. The variation with time t of the vertical velocity v of the rocket for the first 0.3 seconds of the flight is shown in figure here. Yani simply here you have a graph which is in between velocity and the time, or simply you can say v against t. So this is what we have here. The other information says that as the rocket moves, the thrust force T provided by the rocket engine is 16 Newton. So what we have, the upward force is T, which is nothing but the upthrust, and because of that of course the rocket is moving up. Assume that the mass of the rocket is constant for this part of its flight. This part of the flight, be careful, not always, but for this part of the flight, what you have to do, assume that air resistance is negligible. So they are assuming another thing, two main points. Assume that mass of the rocket is constant for this part of the flight, and there is no air resistance. So assuming that these two things, what we have to do in part A, we have to calculate for this part of the rocket's flight. We have to show what we have to show that the acceleration of the rocket is 55 meter per second square. So simple thing is that they are saying that the rocket is you can say starting from rest or move from rest when t is equal to 0. So it means that the initial velocity is 0, and you know that formula of the acceleration is this one, a is equal to v minus u divided by t, where v is the final velocity, u is the initial velocity, t is the time, and of course here we are talking about the vertical velocity. So of course we can write here, but need not to write because they have already mentioned here that the vertical velocity is v. So you need not to even mention here that we are talking about the vertical velocity, but even if you will write, it will not be wrong. So 16.5 at time 0.3, when you will check this velocity, somewhere here you are, and you can see that each small box is nothing but of 0.5, because from 0 to 5 or 5 to 10 or 10 to 15 or 15 to 20, you have 10 divisions or 10 small boxes, and here you have 5, yani 0 to 5, 5 to 10, the intervals are all 5s. So simple thing is that when you will divide this 5 by 10, you will get 0.5. So here this is the value of 15. Here you have 16, yani 0.5 difference is here. So 15, 15.5, 16, 16.5. So 16.5 meter per second is the final velocity, which is at 0.30 second. So this is what we can take here, and of course you are getting here by simple calculation that acceleration is equal to 55 meter per second square, and actually this is what you have to show. So this is the simple part, and you have shown here that the acceleration is nothing but 55 meter per second square. Now the second part state an expression for the resultant force experienced by the rocket in the terms of thrust force T and the weight of the rocket. So simply what you can say that of course the weight of the rocket, if you will consider, the weight of the rocket is acting downwards, and here you have the situation of upthrust. So T minus W, simply you can write in this way, and the ultimate force, which is the resultant force in this case, is given as F. So F is equal to T minus W. This will be your simple expression. Here they are just asking for the expression. So we have written F is equal to T minus W. Remember this thing that I have mentioned here, that here we have a force, but as they have given you the force as something different, and the force here they are saying that is a resultant force. So we need not to mention this force over here. The resultant force will be the result of weight of the rocket, which is of course acting downwards, and the upthrust, which is T. So remember this thing that this T will be equal to the force which is pushing the gases downwards. You can use F dash for that particular force, but over here the resultant of these two forces T minus W will be RF, as they are mentioning here that the resultant force is F. So that's why it's better to use F here, not for the force which is acting or pushing the gases downwards. So this is what we have. The next part says calculate the mass of the rocket. So here simply you can say that the resultant force, as you already know, that F is equal to ma. So the resultant force, as we have just mentioned, that resultant force is equal to T minus W. So what is resultant force, and what this force is doing? Producing an acceleration. And for this we already know F is equal to ma. So F is nothing but ma, and W, which is the weight, is nothing but mg. And if you want to know, or if you want to calculate mass, so what you are doing, you are taking this part on the other side, and in this way here you will consider, or you will take mass as constant, so A plus G. So simply this equation you can change in this step, that M is your subject, T divided by A plus G will be your acceleration plus acceleration due to gravity, and ultimately when you will calculate, you are getting the result as 0.25 kg. So remember this thing that you need not to mention here kilogram, but of course whatever the calculations you are doing, you must have this consideration into mind, that the unit is coming as kg. So this is important, that you need not to write the unit, but it's already written, so you have to consider everything in SI unit. Done? It's okay. So this is what we have as far as the mass is concerned. Now as far as the part B is here, at time t is equal to 0.30 second, a small piece of metal separates from the rocket. So what is going on in this case? As we were saying that first the rocket was moving, and now in this part they are mentioning here that at time t is equal to 0.30 second, a small piece of metal separates from the rocket. It means that now the of course mass of the rocket is changing, you can say. Calculate the height of the rocket above the ground at this time. So simply you can say that as far as the height is concerned, before you can say of the separation of the metal piece, simply you can say that height is nothing but the area under the graph, because we know that when we have velocity time graph, the area here, this area is nothing but the distance covered. So remember this thing, that distance covered is the area of v into t. And of course as you have here the zero value and here you have a particular value, of course 16.5. So the area under the graph is very simply you can calculate, and this is nothing but the situation like this, that s is equal to half v into t. Basically, if you will recall the whole situation, the average velocity you have to consider, which is nothing but initial velocity plus final velocity into time. But as the initial velocity is 0, final velocity is 16.5, so you can write in this way that the time is 0.30, and ultimately I have written this in this way, simply half base and the you can say vertical side, and ultimately you are getting this value, and 2.5 will be the height at which you will be when the time is 0.30 second. So be careful. Now as far as the other part is concerned, the speed at which the piece of metal strikes the ground. Now this is very important to understand and to recall that here we have the formula, which is the third equation of motion, v square minus u square is equal to 2ah, because here you actually are talking in terms of vertical velocity. So as we mentioned that even if we are not writing v, it doesn't make any difference. But the main point is that the acceleration which we have calculated somewhere here, 55, is no more you can say the acceleration of the metal piece, because now the metal piece is not the part of the rocket and it is just moving as a free body, or have a free fall. So simply you can say that this acceleration we can write in this way, that this a is basically g, and you know that the value of g is 9.8. So just use these values and you will get the value of the velocity with which the piece will hit the ground or strikes the ground, which is nothing but 17.9, or with significant figures of 2. Here you have 18 meter per second. So this is what you have as far as the second part of part B of this question is concerned. Is it clear? I hope you are understanding what we are discussing. Fine. So this is what we have. Now this question number 3, based on the principle of moment and other you can say topics. Like here you have the first part of question number 3, state the principle of moment. So you already have a sort of definition or the statement of this principle. Simply what we have written here, that the for a body in rotational equilibrium, the sum of the clockwise moment is equal to the sum of anti-clockwise moment. So remember this thing, that whenever we are talking about the moments, moment is something which is of course ultimately rotating a body. So of course if the body will be in rotational equilibrium, then this principle will be applicable. So principle of moment is simply for bodies in rotational equilibrium, and the sum of the clockwise moment will be equal to the sum of anti-clockwise moment. This definition you should know. And remember this thing, that almost in every question you will see these types of statements or definitions they are asking. So if you can remember by heart these definitions, so this will be a good practice where you will not waste time just to recall that what was the definition, because you need more time to solve the problems. Like in part B, you have a big figure and you have to understand this figure, and then you have to apply your knowledge of the moment, principle of moment. A hollow plastic sphere is attached at one end of the bar Here you can see that they have given you up the diagram. Here you have the hollow cylinder or a sphere, and this is attached with a simply a bar. The sphere is partially submerged in water, and the bar is attached to a fixed vertical support by a pivot P. So here you have pivot P, and of course the situation is that you can rotate this sphere. Here you have the fixed support, as you can see pivot is here at point P. The sphere has weight 0.30 Newton. Now they are giving you another information that the weight of the sphere W is nothing but 0.30 Newton. The distance from P to the center of the gravity of the sphere is this much, 0.29. So they have mentioned here that this distance is nothing but 0.29, which is between the distance between pivot and over here the center of gravity. And you know that center of gravity is the point where we consider the whole weight of anything is acting. Okay, so this is another very important. You should know the definition of the center of gravity, not for this problem of course, but they can ask you this definition number of times. Okay, assume that the weight of the bar is negligible, so they are not considering the weight of this bar. So this is a easy part, you can say. Calculate the moment of the weight of the sphere about P. Calculate the weight. So you have to recall that what is the moment. So simply moment is nothing but a very simple formula. You know, this is the force into the perpendicular distance from the pivot. So this is the simple formula as far as the moment is concerned. So which force is here? Force is nothing but weight in this case. In this case, force is nothing but weight. But you have to actually calculate, or you have to have an understanding of the you can say the perpendicular distance. So what is the perpendicular distance in this case? So I have drawn here, like here you can draw a line. I am just drawing again. Here you have to draw a line which is passing through the pivot. This will help you to find out the perpendicular distance. And another line you will draw through the weight or through the force. So very simply you can say that the perpendicular distance of your force from the pivot is nothing but this distance. So be careful. This is the distance. This is the perpendicular distance, because the force is acting somewhere here, and this will be the perpendicular distance. And this is actually the point where number of times our students have a sort of confusion. So just to get rid of this confusion, always draw a line which is passing through the pivot vertically and horizontally. And if you have one force or two force or three forces, now we can simply, you can get the perpendicular distance. In this case, perpendicular distance is nothing but this distance. You can say that it is point A and point B. So now what is this distance? So you can consider this is a sort of triangle here, like as they are mentioning that this is the angle 40 degree. Of course here you have 90 degree. So here you have angle which is 50 degree, because 40 plus 90 and 50 will give you total angle which is 90 degree, 180 degree. Now what is this part? Yani, if you will consider the triangle, then which triangle actually you are considering, and where you have this angle, and what will be the perpendicular distance. So simply you can say that here we have the distance, or this is the distance which is perpendicular distance. And you have to recall that if you want to calculate the x component any vector, this will be v cos theta. So in this case, what is the situation? The length is given from this point to this point, which is, of course, you can write in this way, that Lx, L cos theta. So what is L in this case? 0.29. And what is cos theta? This is 40. So this is simply you can use here, and you are getting the situation of this with the help of this formula. You can write moment of the weight of the sphere is nothing but weight into the perpendicular distance. This is your force and this is your perpendicular distance, and of course both of these values you have. So simply you can calculate the moment of the weight. Be careful. So this is something which is already you can say unit is already given. 0.07 is the value. So this will be the moment of the sphere. Okay, so this is the part B of this question 3. Now in part C, the system shown in figure 3.1 is a part of mechanism that controls the amount of water in the tank. Basically, if you can recall, like we have a flash system, we can use this type of system that the hollow ball or sphere is moving up when the water level is rising. Water enters the tank and causes the sphere to rise. This result this results in the bar becoming horizontal, yani slowly and gradually. When the sphere is moving up at one stage, this bar, which was making an angle before somewhere here, this was the angle 40 degree. Now the sphere has moved up, and somewhere here your sphere has a new position because of the water rises in the tank. Now figure 3.2 shows the system in its new position. This is the new position. Okay. Then what is happening again? In this position, the rod R, here you have the rod R, exerts a force to compress horizontal spring that controls the water. So what is happening? This is the force of compression, and here you have the situation that controls the water, yani no more water will go into the tank. Water supply to the tank. R is positioned at perpendicular distance of 0.017 meter above P. So what they are saying, that here you have pivot. Again you can do the same thing. You will draw a line here passing through your pivot, another line again passing through your pivot, vertical and horizontal lines, which will you can say help you to get the idea that which force has what you can say perpendicular distance. The variation of the force F applied to the spring with compression X of the spring is shown in figure. So here you have the graph which is in between F and X, yani load or force, and this is of course the you can say change in length. In this case this is not expansion but compression, but we know that whether it's a compression or expansion, we have the relation between load and the effect of the load. So F is equal to KE or KX. In this case you can write KX. So this is what we have. Use figure 3.3 to calculate the spring constant. Basically this part of the question is from the deformation, chapter deformation. And of course the spring constant you know is nothing but K. So the spring constant first you have to calculate, it is F over X. So simply you can say that as far as this graph is concerned, this F over X is giving us, and the gradient of the graph is giving us the value of K, which they are asking in this part 1 of your part C of question 3. So very simply 21 divided by 10 into 10 to power minus 3. Why? Because here you have again simple thing that 20, 20.5 and 21. And of course here you have the extension or compression, in this case not extension, millimeter. So this is what we have, and simply you can calculate this very simple you can say thing, which is the gradient, or simply you can say the spring constant. So you can recall that spring constant is nothing but the stiffness. Again if you want to go to the detail of the theory of this problem, so go to my lecture on deformation, and you will get a better idea and understanding of the value of K and so on. In second part, the position shown in 3.2, the system is stationary and in equilibrium. So what they are saying ultimately, that they are showing you here the situation when the system is in equilibrium, and of course here you have certain forces, and these forces with perpendicular distances, you can get the idea that what will be the situation here. So the radius of the sphere, they are just mentioning here that the radius of the sphere is 0.0480 meter, and 26.0% of the volume of the sphere is submerged. This is very important part, in which they are just telling you that only this much percentage of volume of the sphere is submerged, yani this volume will be displaced. You can say the water volume will be displaced, of course, with the help of this volume of the sphere. The density of water is given. Show that the upthrust on the sphere is 1.18 Newton. So remember this point, that the upthrust, actually you have to recall, this is another part of the forces, and this part is of course the part of the forces, chapter forces. And you have to recall that upthrust is nothing but the weight of the water displaced by any you can say object. So actually what we have to do, we have to get the calculation of the weight of the sphere, which was you can say displacing the water, or simply you can say upthrust is nothing but the weight of the water displaced by the sphere. So this is important. So these are few steps which you have to consider. So first of all, you are calculating the volume of the sphere, total volume of the sphere. You know that volume of the sphere is nothing but 4/3 pi r cube. So you will calculate the volume, which is nothing but 4.6 into 10 to the power minus 4 meter cube. After this step, what you have to do, you have to find out the volume of the water displaced by the submerged sphere, because this is total volume, but they are mentioning here that only 26% of the volume of the sphere is submerged. So what you will do, when you will multiply this 26%, you will get the value of the volume of water displaced by the submerged sphere, and of course the unit again is meter cube. Now as far as the upthrust is concerned, as I said, that upthrust is nothing but weight of the water displaced by the sphere. Again, I am just mentioning that if you want to go to the detail of the theory of this upthrust, go to my lecture on upthrust in forces chapter, and you will get the detail of this you can say upthrusting as far as the theory is concerned. Now the point is that here you have m into g, weight is nothing but m into g, and if you can recall that density is nothing but mass per unit volume. So to get the mass, you have to multiply the density by volume. So the density is given as here, the density of water is given, and volume you have just calculated here in this step, in the second step. So third step is just giving you the idea that density, volume and g values you have to use, and ultimately you will get the value. Remember this thing, that I have written the value of g first, so you should not have a sort of confusion. Here you have the v thing, and ultimately the density I have written here, and the calculation says that it is 1.179, which is nothing but 1.18. Again, as I said before, that if you have a question like this, show that, so this will be an easy task, because the answer you can say is given, which is 1.18. So actually what you have to do, you have to only prove or show. So 1.18 Newton. Remember this thing, that upthrust is nothing but a force. So this is very important, that you are basically calculating the force when you are calculating the upthrust. Now in the third part, they are saying by taking moments about P determine the force exerted on the spring by the rod R. So simply you can say in this case clockwise moment is equal to anti-clockwise moment, because they have already mentioned here that the stationary system or in equilibrium terms when you have, so it means that of course the clockwise moment is equal to anti-clockwise moment. So what is happening in this case, go back to the diagram. Here you can see that the weight is acting downward, upward is of course upward. So the subtraction of these two will give you the resultant force. And of course when you have somewhere here the resultant force will have the perpendicular distance, which is nothing but 0.29, and then of course you can calculate the value of F as well. What is F? They are saying that determine the force exerted on the spring by the rod R. So this is, I am using for this force I am using F. Over here the net force into 0.29. So what is net force? The upthrust minus the weight, and of course the perpendicular distance is 0.29. Actually when you will have this multiplication, then the whole system will be in or will come in equilibrium. Of course before this there is no concept of equilibrium, and this force F multiply by this distance 0. Here you have this distance 0.017. This is giving you this equation of anti-clockwise and perpendicular distance is this one. When you will use this information, you will get the value F, which is nothing but 15 Newton. Okay, so this is what we have as far as the force is concerned. The force, determine the force exerted on the spring by the rod R. So this is what we have as far as this force is concerned. This is 15 Newton. It's a long question, so but easy. Of course they have mixed number of concepts here. In part 4, calculate the elastic potential energy of the compressed spring. So again the same thing, you have to go to the discussion of this you can say part, which is EP is equal to half Fx. So the force which you have calculated is 15, and the of course for 15 you have to check through the graph that where is the extension or compression. So if you have the force somewhere here, the extension is somewhere here, which is 7.2, or this is something which is required. So 7.2 10 to the power minus 3 is the compression here, and of course X, as I said before, you can use for compression or for extension. In this case the term is of course compression. So ultimately when you will calculate, you will get this result, which is nothing but 0.054 joules. So this is what we have as far as the you can say problem of elastic potential energy. The value is 0.054. When the sphere moves from position, part D of this question, as I said, it's a long question but not difficult. When the sphere moves from the position shown in 3.1 to the position shown in 3.2, yani initially the sphere was somewhere here, then it moves to this new position. So what they are saying here, the upthrust on the sphere does work. Of course the upthrust is here, so it is moving the body up and it's doing some work. Assume that resistive forces are negligible. They are just making the problem simple. Explain why the work done by the upthrust is not equal to the gain in the elastic potential energy of the spring. So be careful that here basically what we are saying, that the sphere is moving up, of course doing some work, but the elastic potential energy gain is not same as the work done by the upthrust. So why? So very simply you can say that of course there is a gain of gravitational potential energy as well. The gravitational potential energy of the sphere also increases. Simple, yani from point suppose A you are going to point B, So there is a gain of gravitational potential energy as well. So this is what we have as far as the part D is concerned. I hope you are understanding the discussion. And as I said that when you are feeling difficulties, so go to the lectures, the theory lectures which I have uploaded on my YouTube channel, and you can say this discussion I will give you the you can say link of those discussions as well. So this is what we have. So question number 4, here we have part A. The progressive longitudinal wave travels through a medium from left to right. In figure 4.1 shows the positions of some of the particles of the medium at time t is equal to time t naught, and a graph showing the particle displacement of the same time t naught. As you can see that here we have a complete picture. Here we have the figure, and this figure shows the situation. Like here we have actually I have already drawn the answers as I said, but just to give you the idea that actually what is happening initially and then what will happen in the next part, I will write everything. Here you have a situation like the particles are vibrating, and of course they are vibrating along the line of direction of the movement of the energy, and they have shown you here this is the direction of the travel of the waves. So simply you can say that the wave is traveling in this direction, means that the energy is being transferred here. But you know that in case of your longitudinal waves, particles are just vibrating about their mean position. Initially the graph which they have given you is for the initial situation, yani when you will consider the particles at its initial stage t naught. Particle displacement to the right of their equilibrium positions are shown as positive on the graph. So here you have the positive side, and what is the situation? These particles are moving to the right, so be careful. And what about the other position? And the particle displacement to the left are shown as the negative of the graph. So when they are moving here on the left, this is the part which you are showing on the negative side of the graph. The period of the wave is t, so it means that when complete wave you will have the time period will be t. So this is very important. Now the part 1 is on figure 4.1 draws circles around two particles which are exactly one way apart. So you know that if you are considering suppose this point x, and suppose you are starting from this point, so what you can say that here this will be the situation where you will have a complete wave from this point to this point, you will have a complete wave. So it means that if this is your first point, then this will be your second point, or you can make a circle here. Or if you will start from this position, so you can say this is the first particle, and somewhere here we will have the second particle. So any two particles which are giving you a complete wave you can consider, and this will be a situation of the one wave apart, particles one wave apart. So any two particles like this, as I have considered these two or these two or any other. So these will be the two particle situation, one wavelength apart. On sorry, on figure 4.1 sketch a line on the graph to represent the displacement of the particles for the longitudinal wave at time t naught plus t over 4. So it means that if this is a complete wave which you have drawn here, if this is the complete wave which you have drawn here for t naught, so it means that t naught plus t over 4 means the quarter time more than before. So it means that somewhere here you can say that this is the quarter time before, and more than t naught, t over 4 will start from somewhere here. So you can say that everywhere you will have the same situation. Yani if this is the point, initial point, then for t over 4, t naught plus t over 4, you will have this point. Similarly, if this is the point somewhere here, this will be the new point, and so on. So all these points you can draw, and you can say that we are drawing a new wave which is always t by 4 more than t naught. So something like this you can draw. And even if you will go back, you can say that it is starting from somewhere here, which is the negative part. So this will be a new situation, and this will give you a concept of new wave, which is t naught plus t over 4. So remember this thing, that there is no change as far as the amplitude is concerned. There is no change, amplitude is same, and of course the only difference is of time. Wavelength will be same. Yani if you are starting from this point, suppose, then somewhere here you will have a complete wavelength as you had before. In this case, as I said before, this you can consider, suppose this is your complete wave somewhere here. So for the new one, when you will start t by 4 plus t naught, t by 4 plus t naught, you are starting from somewhere here. So of course the one wavelength will complete somewhere here. So this is what we have. And then what they are saying is state the direction of the motion of the particle z at time t naught plus t over 4. So what is actually happening, as we have discussed before, that like these particles are moving towards right, and these particles were moving towards left initially. But in this case, when the particle z was moving initially, you were on the negative side. But when you are on the positive side, you can say that the particle moved towards the right. So simple thing is that you will write in this way, state the direction of the motion of the particle z at time t naught plus t over 4. So simply the answer will be to the right. So this is what we have. Okay. The frequency of the wave in A is 16 kilohertz. The distance between particles X and Y is 0.19 meter. X, here you have the point X, and this is your Y. So you can say and see that as far as this distance is concerned, this is nothing but lambda by 2. So be careful, because if you are starting from this point, you can say that, or if you are starting from this point, you can say that somewhere here this will give you a complete wave. Somewhere here you will have a complete wave. So this distance between X and Y is nothing but half of this distance, which is lambda, and this will be lambda by 2. So this, it means that 0.19 meter is basically half lambda. Calculate the speed of the wave as it travels through the medium. So this is what we have written here. Okay, half lambda is equal to distance between point X and Y. So lambda is nothing but, you have written in this way, that is 2 multiplied by this value, and you are getting this value of lambda 0.38. And as far as the speed is concerned, this is nothing but v is equal to f lambda. F they have already given you 16 kilohertz. So 16 into 10 to the power 3, and of course the distance lambda is nothing but 0.38. So ultimately you are getting this result, which is the value of the speed. I think I have calculated this value not properly calculated, you can say. So basically this value is 6100 meter per second. So this is what we have. And how you can write it? 6.1 into 10 to the power 3, or 6100 meter per second. So this is what we have as far as the speed is concerned. Okay. Now, in part C, a longitudinal sound wave is traveling through a solid. The initial intensity of the wave is I naught. The frequency of the wave remains constant and the amplitude falls half of its original value. Determine in terms of I naught the final intensity of the wave. So you have to recall that intensity is directly proportional to amplitude square, and as other factors, particularly frequency is constant, so simply you can write I naught is equal to constant A naught square, or we can write in this way that I over A square is equal to I naught over A naught square. But what they are mentioning here, that the amplitude falls to half of the original value. So the new A is nothing but half of the original one. So this is what we have written in this way, and ultimately when you will do the calculation, you will get this result that I is equal to 0.25 I naught. Okay, is it clear? I divided by, yani you can write in this way as well, that I1 divided by A1 square is equal to I2 divided by A2 square, or as I have written here, that I have taken I1 as I naught and A1 as A naught. So this is I, the new I, and I2 simply you can say is only I, and over here when you will write a 2 square, simply you can say that it is A square, and what is A? This is half of A naught. So this is I have mentioned here in this way, and ultimately you have calculated the value 0.25. You should not write in fractions but in decimals. So this is very important. Okay, the sound wave in the C now meets another sound wave traveling in opposite direction. One sound wave is coming from this side, another sound wave is coming from the other side, and they are going to superimpose each other. They are going to, you can say, interfere each other, and they will give you the stationary wave. What they are asking is state a condition necessary for these two waves to form a stationary wave. So we should know that for you can say the formation of the stationary wave, the frequency, wavelength and time period, or all of these must be same. So we have written either of one of the factors. Then part 2. State two ways in which stationary wave differs from the progressive wave. So as far as the stationary wave is concerned, you know that they do not, of course, transfer energy. So you can write in this way, energy, stationary wave does not transfer energy as progressive wave does. On the other hand, when you will talk about the stationary wave, in case of stationary waves, you know that the adjacent particles are always in phase, but in progressive wave they are not. So you can recall that if you have something like this, a stationary wave, then all these particles, adjacent particles, are in phase, yani they are moving with the same frequency and they are moving in the same direction as well. So they are always in the same phase. But when you will talk about the progressive wave, you can say that this particle, suppose, is if this particle is going down, this particle is going down, but here you have a situation that these particles are moving up and their distances are also different. So they are not in the phase situation. Yani adjacent particles are not in phase. Okay, so this is what we have. This is stationary and this is the situation of progressive waves. And again, the theory, of course, will give us the more detail of these things. We have two more questions. Question number 5, part A, state Kirchhoff's rule or Kirchhoff's second law. So you have to recall the theory, and this is of course the question from your electricity part, and the sum of the EMFs and the potential differences in a closed circuit is always zero. Here you have you can use one more term, and you can write the algebraic sum of EMFs and potential differences in a closed circuit is always zero, or closed circuit, or you can use loop. So this is what we have. Yani if suppose you have a circuit like this, then you have a potential difference somewhere here, suppose, and of course this will be a source of EMF. So whatever the energy your battery will supply, maximum you can use that energy in the outer circuit. So this is the concept of a loop, and here you have this equation that sum of EMFs and potential difference will always be zero, or simply you can say that the sum of EMFs will be equal to the sum of potential differences in a closed loop. So this is what we have in question. You can see that they have given you 2 marks. So first mark is for this part, sum of EMF is equal to sum of potential difference, and the second mark will be for the closed circuit, and of course is zero. So this is all you have to consider, and you have to write in the same way. This is important. In part B, 3 identical cells, each of electromotive force EMF 1.5 volt and internal resistance 590 milliohm, are connected in parallel across the conductor as shown in figure. So you can see here that the block which I have made by the green color is the combination of your EMFs 1.5, 1.5, 1.5, and this is the parallel combination. Each has an internal resistance 590. So the position is that and of course theory says that 1.5 or whatever the potential you have over here, the the cells are connected in parallel. You will not add the potentials, but of course the current through all these will be added, and you can say and see here that all these three are connected in parallel. So when you will calculate the parallel situation, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is the formula for your parallel combination. So RT will be the sum of all these three resistors. RT, the total resistance, I am writing in this way here, and this is something 1.1 divided by 590 to n to power 3, and 3 you have 3 resistances you have. So what you are getting for this resistance, which is 0.197 ohm. Now when you will connect the circuit in this way, yani the total internal resistance is 0.197. Over here you have conductor A and B, conductor B you can say, then or sections of the cylinders A and B. Now again the total potential is only 1.5. Be careful, not the current, but the point is that they have given you the total resistance here, which is 2.2. So it means that the total resistance is R minus RT. This is your RT. This will give you the resistance of this RA plus B. So this is how you are calculating your RA plus B, and this is nothing but 2. Again you have to show this situation, and you have to show that the resistance of the conductor is 2 ohm. So this is how you are calculating the RA plus B. Then in part 2, calculate the current in the conductor. Now the point is that the potential is only 1.5, and over here you have the total resistance, which is 2.2. So V over R, yani V is equal to IR, will give you this situation that I is equal to V over R. V is as we have just discussed is nothing but only 1.5, and the total resistance is 2.2. So this is what you are getting here, and this is the value of your current, which is 0.68. Okay, so I think it's not a big deal. As far as part C is concerned, what you can use here, just first of all read the question. The two cylinder sections A and B of the conductor in figure 5.1 are made of the same material, yani resistivity is same, and above and have the same length, so the length is also same. So you have to recall this equation that R is equal to resistivity times length divided by area of cross section. So they are saying that the length is same, your resistivity is same. So what is the situation here? Now the second part says the diameter of section A is 4.3 millimeter and the diameter of the section B is 7.6 millimeter. The resistance of this section A is RA and the resistance of section B is RB. And what they are asking, calculate the ratio RA divided by RB. So when you will use this concept, simple thing is that you can write in this way, that rho LA divided by AA and rho LB divided by AB. So even if you are you can say writing over here like in this way, you can say this is rho A and rho B, but as the material is same material, so rho is same. So simply you can say the rho A is equal to rho B and length A is equal to length B. So you can cancel out and the simple relation will be in this way. You can write RA divided by RB is equal to nothing but AB divided by AA. And of course if you want to write the formula for area, so A is nothing but pi, you can write in this way, pi r square, but over here as the values are given in terms of diameter, so I am writing in this way that d square over 4. So here you have this d by 4 is giving you the value of r, because r is nothing but equal to d by 2. So when you will take the square, you will get d square divided by 4. But of course on both sides you have pi and you have 4 as well. So I have already cancelled 4. Pi will also be cancelled out from both sides, and this will be the situation that you are just using the values of your the R, your D, B and DA, and of course you are getting this value which is 3.12. Okay, so this is very important, that how you will manipulate the formula and you will develop a new formula, the ratio of RA RB in terms of diameters. Of course the squares are here. Then in part 2, calculate the ratio average drift velocity or speed of the free electrons in section A, average drift speed of free electrons in section B. So drift velocity and the equation for the current and the drift velocity and all these n is the number of charges per unit volume, A is the area, Q is the charge and V is the drift velocity. So when you will write V, you will write in this way that I divided by NAQ, and as all other factors are constants, only the difference is of area, your area of cross section, so which you have already calculated actually. So again the same value you will get as you are getting here, 3.12 or 3.1, and this is 3.1 as well. So the whole discussion, as I said over here, or after this point, you have the same situation as this value. So remember this point, that of course the numerical values of these two ratios are coming same. So this is what we have. Now as far as the part D is concerned, the circuit of figure 5.1 is altered by removing one of these cells. So when you are just removing the one of these cells, then what will happen? Of course, when one resistance will be removed, so these two resistances will have of course the higher values, because they are in parallel combination. So more you can say resistances in parallel combination will reduce the value of the net resistance. So when you will remove one of the resistance, then the two resistance will give you the higher value. So this is what we are writing here, and what is the question? State and explain the effect, if any, of this change on the potential difference across the conductor. So 3 marks you have, so be careful. First of all, what you will write, as I have just mentioned, that the combined internal resistance, what will happen? Increases because of the decrease in number of resistors in parallel. And as you will have the increased value of internal resistances, what will happen? The total current, of course, will decrease or decreases, and ultimately when the current decreases, you can simply say that the potential difference also decreases. So overall these are the effects when we will remove one of the you can say cell, and as the overall resistance will you can say increases. So what will happen? Of course, the current will decrease, and ultimately potential will also decrease. So V is equal to IR. So this is what we have. In this case, again, we are using the concept of V and I, and of course the R thing, that what is the situation when the R will increase, the current will decrease, and of course the potential will also decreases. So this is what we have as far as the part D is concerned. In the question 6, which is basically from your particle physics, and A, the nuclide carbon 14 6, which is carbon 14, is unstable and undergoes beta decay, emitting a high energy electron and an antineutrino to form a new nuclide X. The equation for this decay is given. So carbon 14 6 is changing into X. Here you have the beta particle, and here you have the antineutrino. So what will be the situation here? The simple point is that as far as the electron is concerned or beta particle is concerned, we take the mass is approximately 0 and its charge is -1. So simply you can say that here you have the proton number or charge, and here you have the proton number. When you will add 7 and -1, so you are getting 6, which is other side value of number of proton as well. And of course this 14 0 and 0 is also giving you the same number. So this is how you can write these numbers, like 14 0 -1 and so on. So this is what we have. Complete the equation. So we have completed the equation. Here in part B1, state the equation for beta particle or beta decay in terms of fundamental particles involved. So basically you have to recall fundamental particles, and these are up quarks and down quarks. So when you will consider this situation over here, the beta particle is you can say with the, when you will consider the decay part, basically something like this, you can write that this is up down down, changes into up up down, and electrons, your beta particles, you have an antineutrino. So this is simply, you can write in this way, that the particle is up down down, here you have up up down, and of course the beta particle, negative beta particle is here, negative beta means electron simply, and neutrino you are getting. So this is how you can write this equation. It's simple. Actually you have to recall that what is up down down and up up down. In the next part we can discuss a little bit about this thing. Use your equation from B1 to show how charge is conserved in beta decay. So as you can see that here you have up down down, and on the other side you have up up down. So what will happen? Simply you can say that we can cancel one up with up, one down with down. So over here you will have down, and over here on the other side of the equation you will have the situation of up. So what is down? The you can say the value of down is -1/3, any charge, any electron. If you have electron E, then down quark is only 1/3e, and similarly up is nothing but +2/3e. And of course you know that Here you have the situation of your electron, so -1 charge you have here, and antineutrino has 0 charge. So in this way you can write the equation, and again the same thing when you will write 2 over 3 minus 1, which is coming from this part. This will give you 3, 2 minus 1, and this is nothing but minus 1 over 3. So this is minus 1 over 3 on the other side as well. So the equation is balanced, and you can write the equation to show that the charges are conserved in beta decay. Is it clear? But again the same thing, you have to go for the theory of this and you can say up and down quarks, and the total charge of your proton, neutron and electrons. All these things are in the discussion, in theory discussion. So you have to of course recall those explanations as well. C. Neutrinos were first proposed to exist more than 20 years before they were directly detected in order to explain particular experimental observations about beta decay. So they are just telling you that neutrinos have already discovered, and you can say beta particles we have to explain. So what is part A? State an observation about beta decay that is explained by the existence of neutrinos. So this is very, very important, that the beta particles have a range of continuous energy. So this is important, that when the beta particles have continuous range of continuous energy, so how it is happening? So this is the reason, or you can say the proof of the existence of neutrinos. Suggest how the existence of neutrinos explain the observation in C1. So particles, beta particles have a long range or range of continuous energies. So simply you can say, as I had just mentioned, that the emitted neutrinos takes different energy from total energy. Yani whatever the total energy you have, your neutrinos are getting different energies, and because of that the remaining energy for your beta particles are also different. So you can say that we have a range of frequencies, continuous range of energies, or even frequencies you can talk about, and here you have the beta particle. So this is what we have as far as this paper is concerned. This is 9702 to 3 October 22. I hope you have understood the discussion, but still if you have any confusions, please you can contact me directly, and of course your comments will also be very important. If you are new on my channel, subscribe my channel and share my channel with other students, so they can get benefit of this discussion as well. So inshallah, see you in the next class, in the next discussion. Till then, Allah Hafiz.